AI is moving crazy fast right now, and recently I am seeing a lot of videos where people are running AI models locally instead of just relying on cloud tools. That got me wondering, what kind of PC do you actually need to run these models yourself? So, like many others, first I tried to run a small AI model on my old laptop with 32 GB of RAM and 4 GB of NVIDIA GPU, but the experience honestly was not great. So that's when I started looking into building a proper AI PC capable of handling large models. And that's exactly what this machine is. So in this video, I will walk you through the components of this PC and what this system can actually do. Without wasting another second, let's dive in. Hey guys, my name is Rishabh, and in this video I'm sharing my experience of building a professional PC that can handle large AI models. I will talk about the components I picked for this PC and also the models I can run on this PC easily. Just a quick heads up, this is not a step-by-step PC build video, it's more about the components and the capabilities of this PC. So with that out of the way, let's start with the first component of this PC, the case. Okay, so let's start with the case. I know most people don't think too much about the case. Like, as long as the parts fit, it is looking good with all the RGB lights and all, right? It's fine, right? I also used to think like that. But this PC is different. This is a workstation, right? I'm planning to run heavy AI models on this, and not just for a few minutes, I mean, for a long time. And when you think about it like that, then the case actually becomes more important than you think. So my two main requirements were good airflow and enough space for the future. Now let's talk about airflow. I mean, this case is built around airflow. Behind the wooden front, there is this big mesh, which I really like. I mean, because I have lots of cats at home, and there is this cat fur all over the place in my house all the time. So good dust filtering system is very important for me. And behind that mesh, Asus added these 200 fans, two of them. I mean, look at this in the front. Just look at the size of these fans. I mean, these are massive. They move a lot of air, and they are also surprisingly quiet, which is perfect when the PC is running heavy work for many hours right next to when you are sleeping or you are doing something, right? The wood in the front gives it a personality, but it is still simple and clean. It does not look too much. And here and there are also added some practical things like two less panels, removable dust filters, GPU support brackets. I mean, these are small things, but still they matter a lot. And then this case is made for powerful systems and not for just looking nice. So that's the case. Let's talk about the next component. So let's talk about what's inside this case. I want to go through everything: the processor, the motherboard, the RAM, the storage, the cooling, the GPU, and the power supply, all of it, because every single part here has a reason behind it. This is not just random parts I picked. So let me explain one by one. Starting with the processor, I went with the AMD Ryzen 9 9950 X3D with 16 cores and 32 threads. Now, this is one of the most powerful desktop processors you can buy right now. And the reason I picked this one specific, the X3D version, is because of the 3D V-cache technology. Basically, AMD stacks extra cache memory directly on top of the processor chip. And what this does is it gives the processor much faster access to data. So for tasks like running AI models, doing simulations, or heavy multitasking, the performance difference is very noticeable. 16 cores also means I can run many things at the same time without the system slowing down, which for a workstation is very important. Now, talking about the motherboard, I went with Asus X870E gaming. The X870E chipset is the top chipset right now for AMD processors. Now, I picked this specific board because it supports everything I need. PCI Express 5.0 for the GPU, fast NVMe slots, and it can handle all the full 9950 X3D without any problems. It also has very good power delivery, which matters a lot when you have a very heavy processor like this running at full load for a long time. You want a board that can handle that properly, and this one does. I also wanted to stay in the Asus ecosystem as much as possible for this PC, which you will see as we go through the other parts. Now, talk about the storage. I went with Samsung NVMe M2, the SSD with 2 TB storage. Samsung NVMe drives, I think they are very reliable and fast, as well as the read speeds, the write speeds. And personally, I have used Samsung SSDs for years now, and I think I never had any issues with any of the storage drive I have used. And for a workstation where I'm working with large model files, large data sets for training and all, having fast storage is important. Everything loads faster, everything saves faster, and 2 TB is kind of enough space to work with comfortably. But I think in the near future I will be upgrading to 4 TB or 5 TB anyway. Now let's talk about the RAM, and this one is very excited one as well. I have about 96 GB of T-Create DDR5 RAM, and with 6400 megahertz. Well, I would say 96 GB is pretty good, but for a workstation like this, I still feel like I should have about double of this size. So maybe in the near future, I will add two more sticks to it. So first, 96 GB, that's a lot of RAM currently, and the reason is simple. When you are running large AI models, the model data has to live somewhere in the memory. More RAM means I can load bigger models, run more things at the same time, and the system does not struggle at all. For normal gaming or everyday use, I think this is way more than needed. But for this workstation where I'm gonna work heavily related to models, AI models, and all, I think it is actually the right amount. If not, I think it's less. And 64 megahertz speed means the data is moving between the processor and RAM very fast, so everything feels very responsive and even under heavy load. Now, talk about the CPU. We already talked about CPU, so let's talk about the GPU. Now, this is the main component of this whole build, because we are creating an AI workstation, right? So for an AI workstation, we need a really good GPU as well. For this one, we have Asus Astral RTX 5090 OC edition with 32 GB of VRAM. This is the most powerful consumer GPU available right now, and I actually had taken a look at the A6000 as well. So maybe in the near future, maybe I will make a video on 6000 as well. But for now, for my AI work, this GPU is honestly more than I need currently. And talking about the AI models, like big AI models like image generation or large language models, machine learning, all of those things, they can run on this GPU. This is like more powerful, the GPU, the faster everything is. And 32 GB of VRAM is a big deal. VRAM is basically the GPU's own memory. When you run a large AI model, it needs to fit inside the VRAM. And with 32 GB, I can run very large models locally without any cloud, without any subscription, just on my own machine. It is actually really good for your own use cases, experimentations, fine-tuning AIs, and if you want to learn more and more about the AI world. So this is one of the things I wanted to explore. So I went with this 32 GB of VRAM RTX 5090. The Asus Astral is just a very well built card, I would say. The cooling on it is excellent. The build quality is premium, and the OC edition means it comes with a slightly higher clock speed out of the box. So you're getting a little extra performance without doing anything yourself. Now let's talk about the cooling system, which is very much important for a workstation, PCs like this. Now with a processor like 9950 X3D and a GPU like 5090, cooling becomes very important, right? So I went with the NGXT Kraken Elite 360 AIO liquid cooler. 360 mm means it has three 120 mm fans on the radiator, more surface area, more airflow, better cooling. And the Kraken Elite also has a screen on the pump so that you can just display things like temperature, and you can also add your own custom images, GIFs, whatever you want to, which I think that's a nice feature as well. But I think for my PC, which is like a metal side panel, but for a tempered glass panel, I think that would be a really good add-on. But more importantly, it keeps the 9950 X3D cool even under full load, and that's what I wanted. And in a workstation that is running heavy work for long hours, you really want your processor to stay at proper temperatures. And if it gets too hot, it will slow itself down automatically to protect itself. So good cooling means it can run at full performance the whole time. Now, everything needs power, right? I mean, these all are power hungry components. So for the PSU, we have Asus Torf 1200 watt Platinum 3. Now, 1200 watts sounds like a lot, but with 9950 X3D and 5090 RTX, both running at full load, you need this kind of PSU. The 5090 alone can pull a lot of power under heavy use, so beware of that. So I wanted a PCU that has enough headroom and does not struggle at all. This platinum rating means it is very efficient, so less power is wasted as heat. And Asus Tor is a very well built power supply, fully modular, so only the cables I need are connected, which also helps with cable management and airflow inside the case. Now that is everything inside this machine. Just to give you like a summary, like we had Ryzen 9 and 9950 X3D, Asus X870 motherboard, 96 GB RAM at 6400 megahertz, 2 TB of Samsung and NVMe SSD, and ZXT Kraken Elite 360 cooling, Asus Astral RTX 5090 with 32 GB of VRAM, and the Asus Tor 1200 watt PSU fitting inside comfortably within this case PS602 Pro Art. Now every part here has a specific reason. This is not a gaming PC. This is a professional workstation built for running AI, experimentation with AI, and I think the parts reflect that. So now in the next video, I will walk you through like how this all parts fit together and how I'm running models like experimentation, the fine tuning, and which models I can run easily, what's the tokens per second, and what's the performance looks like. Okay, so now let me show you what this machine can actually do. So for this, I built a small application. I call it Beast. And from this one place, I can chat with AI, generate images, generate videos, music, and also experiment with agentic AI. So let me go through everything one by one. Let's start with the language model, the models I use for chatting and thinking. GLM 4.7 Flash, the main model. So the main model I use for every day, that is GLM 4.7 Flash. This is a 30 billion parameter model. But the interesting thing is it uses something called MOE, Mixture of Experts Architecture. What this means is, even though it has 30 billion parameters, only 3 billions are actually doing work at any time. So it is like having a very large team, but only the right people are called for each specific job. Now I run this model through VLLM with AWK 4-bit quantization. In simple words, quantization makes the model smaller without losing too much quality. So this model, which is normally 31 GB, now only takes 6 GB of VRAM. And the speed is fantastic as well. It's around 100 to 200 tokens per second, which is basically real time. It feels like you're talking to a person. Talking about chat, it handles normal chat pretty good, and tool calling, agentic tasks, and it has about 65,000 of token context window. That means you can give it a very large amount of text, like a full code base, and it will process all of it without any problem. The next one we have is Chuan 3.5 35 billion. You must be wondering why I'm calling it Chuan, not Quen, but it's actually called Chuan, not Quen. This is for serious thinking. Now, when I need something more serious, like complex math, code analysis, deep reasoning, or something complex, then I use Chuan 3.5 35 billion parameters model. This is also a MOE model, 35 billion total parameters, but only 3 billion active at a time. It runs through Olama and uses around 60 GB of VRAM. Talking about the speed is around 40 to 60 tokens per second, a little slower than GLM because it is doing more thinking, but the quality is very good. Benchmarks actually show it performs better than many dense 70 billion parameters models on reasoning tasks. And it also supports vision, so you can send images along with your text, which is pretty good. The next one we have is Chuan 3 Coder Next, and this is specifically for coding only. So for coding specifically, writing code, explaining code, fixing code, I have Chuan 3 Coder, and this is Alibaba's model made specifically for coding task only. This is also what powers my client setup in VS Code. So when I'm writing code in VS Code, this model is running locally on this machine, which means no cloud API or GPT API, no internet at all I need. Everything is local, and I can build pretty good applications as well, which you can see on my screen as well. Now let's move on to the media types, which is image. The images are pretty recently after Nano Banana Pro and so many images models going out there on the internet. I have seen images are one of the hot topics. So I am using Flux Point 2 Dev, which is text to image model, which is really good as well. It is not as good as Google's Nano Banana because we are using it on a 32 GB RAM, and I'm running it. And it is from Black Forest Labs, and this is I think this is their latest model. It uses a Mistral 3 text encoder with Flux 2 transformer, and it runs in 4-bit and a 4 quantized format. Total VRAM usage is about 26 GB. Speed is around 15 to 20 seconds per image at 1024x1024 size, which is pretty good as well. And the quality is noticeably better than Flux 1. Better faces, better text images, more realistic results overall, as you can see on the screen. And you type in a prompt, and in about 20 seconds or 25 seconds, it generates a screen on your screen. So no mid-journey, no subscriptions, no credits needed, just local. And everything stays on your system. So data privacy, if you're concerned about that, then you can use that as well. Now, moving on to the video models, which is another hot topic, and this is where we use like maximum of the VRAM actually, because these video models are pretty heavy. For this, we use one 2.2 or 14 billion model, and this is our main video model. This is about 14 billion as mentioned, and it generates about 720 pixel video of 10 seconds, and it can take up to 8 to 10 minutes as well, depending on on your prompt, on the details you have used. And it takes about 20 GB of VRAM. It can go slightly higher as well, but it works within our 32 GB of VRAM we have in 5090. The motion quality on this model is generally good. Smooth movement, realistic physics. For a locally running model, I think this is very impressive. For the agentic AI capabilities, we are still experimenting. I'm still working on it. So far, I have not gained much success in this field, but still, we have done a lot of things. Like, for example, on this chat, if I just turn it on the agent, then we have a lot of tool calls. If I have to show you like what are all the tools we have, all the skills we have app control, automation, calendar, computer, creative studio, files, habits, alerts, and profile. There are like about 157 tools, 26 skills, and we have memory as well, so it keeps the memory of like what your preferences and all of those things. So this is handy in terms of like if I ask my AI, like I will ask GLM, like I want to create an image of a cat. So what GLM will do is GLM will take the prompt and it will just add more details to it, so that our image model can take the prompt and create a really beautiful image, as you can see on the screen. So if you just directly prompt the image model with not so good prompt, some basic prompt, then you might not get really good images. But what we have done is we are using GLM in the middle, so that it can generate a good prompt for the image model. As well as we are using the same agentic capabilities for the research and workflows as well. Like for example, if I have to suggest find out some products like shoes or anything like that, laptop, mobile, or anything, I can just type in my all the websites that I want my agent to just scroll, scrap and find out the information about the products. It will just go on the all the website, it will get all the details of the products, and then it will just give me a detailed answer as well as their suggestions, like which product I should go for. Of course, it's not 100% right at the moment, but this is what we are doing, right? We are experimenting. Thanks for watching the video. If you would like to learn more about what I am doing with these AI models, please subscribe, as I will be posting more videos soon with more details, more experiments and updates. And if there is any specific AI model you would like me to test on this workstation, please leave a comment below.